Hello Matrix, welcome to another video, and here we are again doing paper 1, trial paper from this past September 2022. This was the paper written in the Northern Cape, and it was a request by one of you guys. So we're just going to look through it from the beginning to the end to try and give you one last chance to review a full paper with me. Okay. I know, of course, guys, I cannot ignore the fact that you guys have done superbly. You've really helped grow this channel to this very useful resource it has become at this point. And then I really thank you a lot for it. And I hope you've been able to learn as well as much as possible, and that you benefited greatly towards these coming finals. Otherwise, guys, we're not gonna say too much. We just want to get to the work and start doing it. Yeah, let's see if we can be able to keep the time as well. So let's have a look at question 1.1. It's our standard solve for x type of question. So we are given 3x squared minus 2x is equal to 0. When this quadratic equation is like this, it's much easier to take out the highest common factor, which is x. Okay, and then of course we know we can say x is equal to 0 or x is equal to 2 over 3. Okay, now this is pretty easy, so you get a mark for your factorization here. I don't know why sometimes my hand just refuses to do its thing. And then we have a mark over there and the other one. And then of course make a habit of double checking whether if you plug 0 where x is, will you get 0 equal to 0? The answer is yes. If you plug a 2 over 3, we get here a 4 over, we get a 4 over 9, and then 3 goes once to itself and 3 times to 9, so we get a 4 over 3 here. When we plug a 2 over 3, we get a 4 over 3. So 4 over 3 minus 4 over 3 gives us 0. So these solutions hold. All right. So let's get to 1.1.2. Here we are given a standard quadratic x squared minus 5x plus 2 is equal to 0. All right. So with this one, it already tells you cannot factorize. So we go straight to the quadratic formula. Of course, completing a square and using the quadratic formula is one and the same thing, but rather approached differently. So it's b squared minus 4ac all over 2a. So all I'm trying to say is that it is pretty much the same thing. So rather go for the easy one, which is to substitute into a formula, rather than go through the process of troubling your mind. Okay, minus 4 into 1 into 2. And then we're going to have 2 into 1. So I can make my conclusion. Of course, make a habit of cleaning this up and sorting out the discriminant nicely. But we're trying to save as much time as possible. But the issue here is when you are trying to save time, you may find yourself compromising this whole solution here. But let's take a chance and see. We will test our value at the end. That's another way you can ensure that you don't lose marks at all, is to make sure you checked that solution. So what I'm getting here is 0, comma 4, 4, or x is equal to so this one is 5 highway naman simple. Heban. This thing is a shy match. This is 4, 5, 6. Okay. So of course you want to double check that these solutions rounded off to the nearest integer, well, they give us 0. So let's put the 0,44, then all squared minus 5 into 0,44 plus 2. So I'm getting a number that is very small. It's 0,006. So rounded off to to no decimal place or to the nearest, it's effectively 0. So this is good. So I'm not going to check the other one. You can just do the same. Otherwise, these solutions work. And then, of course, the correct substitution into the formula is what makes it even more nice. Okay. So let's do 1.1.3. All right. So it's a lovely inequality there. So let's see. It's 1 minus x into x minus 4 is greater than or equal to 0. Okay, not a problem. So when they have done our job already, so we just simply take our binomial factors into our lovely algebraic table. I don't know what this table is called, so I'm just gonna call it an algebraic table. Or if you like, you can say it's an arithmetic table adapted for algebraic equations, because it must be some sort of an arithmetic thing, but adapted for algebra. As we know that these things are so closely linked, it's almost difficult to separate them into parts. Okay, so if we solve for x here, we get 1, and then if we solve for x here, we get 4. All right, so this is where these values are, or your critical values. Then, of course, we ask ourselves, when will this binomial factor, for what values of x will it be 0? When x is 1. When we put a number greater than 1, say a 2, we get a negative answer, we get a negative answer. So basically, we're going to test the values between 1 and 4. You test 4, you test values greater than 4. And then what about greater than values less than minus 1? You put a 0 there, we get a positive. Of course, if you find one side as negative and you have a 0 in between, the other one logically is going to be positive. Then for what x values will the second binomial factor be 0? At 4. Okay, and then if we put a value greater than 4, say 5 minus 4, we get a positive answer. Then if one side is positive, the other one is logically going to be negative, but you can double check just to make sure. So we do the product, meaning that bracket multiplied by that. So a positive multiplied by negative is a negative. 0 multiplied by any number is a 0. A negative multiplied by negative is a positive. 0 multiplied by any number over there gives us 0. Negative multiplied by positive is a negative. So where are our solutions here? Well, 0 is included, so we have our circles there, but they are filled in to suggest that this is included. And then, of course, the product is greater than 0 between these two values. So that is where our solution lies. All right. So we can make our conclusion and say, therefore, not you, sir. We can say, therefore, our x must be less than or equal to 4, greater than or equal to 1. All right. So this is as easy as that. And then, of course, they were giving 4 marks, which I wonder. But maybe we can say for critical values, you're getting a mark. For putting these into a nice table, you get another mark. And then usually that format gives us 2 marks. All right. Great stuff. And then, of course, others may write this solution as x is an element of 1. Oh, 4, and then of course those values are included. And then of course you may have thought of solving this one graphically, which is still allowed. Okay, so if we do this one graphically, hi Wenaman, why are you? This thing likes to make me unhappy, you know. So we know that our critical values is 1, 2, let's say 2, 3, 4. So we are only interested in 4. Yeah, ne? So I don't know what is happening here. And then we're saying this is 4 over here. And then of course our y-intercept is going to be a minus 4 here. Alright, so if we draw our sketch, it does something like this. Okay, so our sketch is something like this one. I don't know, my hand is just doing its thing today. I'm not comfortable at all, but in any case, how did I know my graph is doing that, by the way? So you know that if you multiply these x's, you get a minus x squared. So that value there, that sign of a, already tells us that we're looking at a grumpy face, okay? Sorry that I didn't indicate that. So that is fine. So this is how we know. And then of course we are asking ourselves, it is 0 here at this intercept and that intercept, and these are included, and then our solution lies in between because the graph here is greater than 0. And then of course we can make those conclusions from the graph. So you can get a mark for the tool chosen for answering. Okay, so that is fine. So we have 1.1.4. Okay, what is that? So we're getting that radical there, which is x equals 1 plus root 7 minus x. Okay, so we have x is equal to 1 plus the square root of 7 minus x. Okay, so we always isolate the surd. So it's going to be x minus 1 equals the square root of 7 minus x. Then at this juncture, you want to remove the surd or the square root. So we remove it by doing an inverse operation, which is to square both sides. Of course, what you do on the left hand side, you are to do on the right hand side. Okay, so this is good. So we FOIL this out. It gives us x squared minus 2x plus 1 equals, and then here we simply take away the blanket. Okay, so when we yank all those curtains, what happens? We can transpose x to the other side, so we get x squared minus x, and that we bring in 7, it becomes minus 6 equal to 0. So we can factorize this. And how do we do that? Of course, what are the factors of 6? Basically is a 3 and a 2, but we want that to be negative, so we're going to do that just like that. All right, so therefore x is equal to 2 minus 2, or x is equal to 3. The question is, which one of these is allowed? Now, the best way to make sure that everything is correct, you test whether you will have the left hand side equaling the right hand side, and 2 under the square root sign, there must be no negative. So let's start with a minus 2 there. We put a minus 2, then we put a minus 2 over here, so we get a 9. Square root of 9 is 3. 3 plus 1 is a 4. So minus 2 is not equal to 4. So basically this one falls away. We put a 3 in there, And then what do we have? So it's going to be 7 minus 3, which is 4. Square root of 4 is 2. 2 plus 1 is a 3, and therefore 3 is equal to 3. So this one is good. Of course, for rejecting that value, you get a mark, okay? For factorizing this, you get a mark. This operation here, the inverse operation, you get a mark for it. How many marks were there? 5 marks, okay. And then, of course, getting this trinomial here is important. Okay, so this is how those marks are arrived at. Let's get a look at 1.2. So what do we have here? Solve for x, and then of course we can just work this one out and say this is the same as 1 plus 2y. We make this one equation 2. We can make this one 1. Okay, it's not a problem. And then of course we put 2 in 1. So what do we get? Where you see x, we put 1 plus 2y. So this is going to be 1 plus 2y squared minus 3. Where you see x, you put 1 plus 2y. And then of course this is multiplied by y plus y squared is equal to 1. This implies that we fall this out, it's 1 plus 4x, oops, no, there's no x here, plus 4y plus 4y squared, okay, minus, and then we multiply by y in there, we get a y plus 2y squared. So when we multiply by 3, it's going to be 3y minus 6y squared, okay. And then we add a y squared here, then we take the 1, and then we leave that one to 0. So you can already see here that a lot of things do a number on each other. 1 cancels 1. And then of course we are left with just a lot of work. So now let's deal with the y squareds. So we have 4 minus 6y. So we get a minus 2y squared, okay? So when we deal with this one, we get a minus 2y squared. Minus 2y squared plus y squared, we get a minus y squared, okay? And then here we have a 4y minus 3y. So this one gives us a plus y. And then is there anything? The answer is no. So that is equal to 0. And then we take out our highest common factor here, which is minus y into y minus 1 equal to 0. So it comes out that y is going to be 0 or y is going to be equal to 1. And therefore we know that x is going to be 1 plus 2 into 0, or x is going to be equal to 1 plus 2 into 1, which is just going to be equal to 1, or x is equal to, this one is a 3, okay? Now let's see, when we substitute this side, when y is 0, x is 1, so we put a 1 in there, and then if you put a 0 there, you remain with 1. The left hand side is equal to the right hand side. You put a 3 there, then we're going to have a 3 there. What is going on? Something is not making sense. So x is 3, then this is going to be 1 plus 2. Okay, sorry, I'm making a mistake. You're putting a 3 for the x, you're putting a 1 for y. Yeah, then 3 is equal to 3. So that means these are correct. Again, guys, make a habit of double checking these values. It's a lot of work here, and there's a lot of marks. So you don't want to lose those marks unnecessarily. So of course you get answers. The x and y values give you the marks, and then of course the most important is substituting into the correct formula And perhaps you can say here substituting the y values back is where you get your 6th mark. Okay, not a problem. Now let's deal with this one. This is grade 11 stuff. Solve without using a calculator, not a problem. So here, show without using a calculator. So the question is show. So that means you have to prove this to be true. So all I'm going to say is that the left-hand side is the square root of 12 plus 2 square root of 3 plus 3 to the exponent 1 comma 5. Okay, this is equal to square root of 12 is basically 2 root 3. So how did I know that? You split this into 2 times 4. The square root of 4 is 2, and then 3 remains root 3. Okay, plus 2 root 3 plus this one, you change it to a exponent, that is a fraction. So this is 3 to exponent 3 over 2. Okay, doesn't look quite nice. So this is 3 over 2. Okay, not a problem. Then these are like terms. So 2 plus 2 is basically 4 root 3. Plus you change this into a surd. When you do that, what is on the denominator? It tells you the type of the root that you have. So it means it's the second root or the square root. Okay, so this is going to be the root of 3 cubed. Okay, not a problem. So this is 4 root 3, then plus, what is that? This is the square root of 27, right? Right. And then we go further and say, well, this is 4 root 3 plus 27 is 9 times 3. And then, of course, the square root of 3 is 3. The square root of 9 is 3. And then remain with a root 3. A root 3, 3 root 3 plus 4 root 3 is 7 root 3. I don't know why you're always trying to sabotage me, thingy. Then if you replace this back inside, so you have to convert this inside. So this becomes the square root of 7 squared times 3. So which is the square root of 147. That is equal to the right hand side. Okay, so they're giving you 3 marks, but there's a lot of important steps here. I don't know where they are giving you the marks. So this is already important, but perhaps there it's much more important. And then whatever we did here is taking us to that. At the end of the day, I do believe that yeah, whatever, man, whatever. So it's a lot of work for just a few marks. Okay, this is how question 1 goes down. So let's rush through question 2. So question 2, we are told here, consider the quadratic sequence. So you will always be told what you are handling. So there we are. We were given a nice sequence here. It says write down the 5th term of the quadratic sequence. So let's answer this quickly. So we have 8, 18, 30, 44. Okay. And then, of course, we're going to have our first differences, right? We know that. So this is 10, this is 12, this is 14, okay? And then we will have the second differences, which is the constant, which is a 2, right? Right. And then, of course, to get to the next term there, what we're going to have to focus on is these situations. So if you add all those up, you'll be able to get to the next term. So this is 2 plus 4, this is 14, sorry, this is 16, 16 by 44, this is giving us 60. So there's the next term. So that is what we were looking for. So I'm sure it is sorted, but you may want to answer down here, say therefore T5, okay, is equal to 60. Okay, Not a problem. 2.2 says determine the general term of the quadratic sequence in the form Tn equals an squared plus bn plus c, which is standard form. Alright, so you need to focus on these folks here. These are your friends when you're solving this quadratic thing. So it's grade 11 stuff, nothing major. So you focus on those and then you work your magic. So you say that 2a is equal to 2 because that is the second difference. So therefore our a is 1. This implies that 3 into 1 plus b is equal to 10. Therefore b is equal to 7. So which also implies that 1 plus 7 plus c is equal to 8. Therefore c is 0. Okay, so this concludes that our Tn is n squared plus 7n. Now let's double check whether this satisfies our sequence. So when we put 1 there, what happens? So this is 1 squared, which is 1. 7 times 1 is 1. So 1 plus 7 is 8. Tick. And then you put a 2 there. So 2 squared is 4, right? And 7 by 2 is 14. 14 plus 4 is 18. So it is giving us our sequence. Let's just check the last one, just in case, you know, everything looks all right, and only to find out it is incorrect. But if we get 60, definitely the last term, the fifth term, we're getting 60. So this formula is representative of our quadratic sequence there. So we're getting our 4 marks. Of course, these marks come from solving for these guys. And then the final key. All right, so 2.3 says determine the first term in the sequence which will have a value greater than 330. Okay, not a problem. So this basically says here Tn must be greater than 330. What is Tn? It is n squared plus 7n greater than 330. Okay, factorize that thing. I know here the problem is that this is a big value, but I mean, you can think about it. What goes to 30? Sometimes I use the last two. 30 can take 15, right? Obviously 5 is not going to work. It can take 10. Maybe let's start with the 10. So 330 divided by 10 is what? Is 33. But the problem is 33 and 10, they won't give us a difference that gives us a 7. So that doesn't work. Let's try 15. 330 divided by 15. So you see, you always look at what kind of a number you've got, okay, that you're trying to factorize, and just look at the factors that would fit in there. Then you're sorted. So 15 fits nicely because I'm getting 22. So the difference of 22 and 15 is 7. So I have n. Then this one is positive, so I must have a plus 22 and a minus 15. Okay. So now remember, this is an inequality, so you're not going to just jump in and start solving. So you have a friend there that says you can't just, you know, indulge like that. Maybe let's choose another color. This one says, no, man, you can't just indulge. So let's see. What kind of a parabola there? It's a smiling parabola. So let's do our thing. So you see, question 1 styles don't fall away. As much as you may not want to carry them through, actually we're not going to put x. So this is the n. You adapt it to the sequences in series, so that is Tn. And then of course that's the origin. So we're going to have a minus 22 here, and then a 15 over there. And of course it's going to be turning at some minus. It's going to be cutting the y-axis at some minus 330, which we're not really interested in the actual value. But let's see. This is going to turn on the side before it goes. So it's something like this. All right, so it's something like that. So we know that this is what our our parabola would look like. Okay, now you are like, hold on, there's a few issues with this. We know that this guy cannot have what you call, this guy cannot have a y-intercept. Why? Because n is an element of natural numbers. Okay, with n being an element of natural numbers, it means n cannot be 0. It starts from 1. So this already tells us that, look, all of this side here is out. Okay, all of this is totally out, so we don't have to worry about it. But where is our solution lying? You can already tell there that, look, we have a solution along here, because where is this graph greater than 0? It's greater than 0 after 15, and that's what we want. But of course, knowing that there is a huge restriction, we only have this portion of our graph. So we can make our conclusion, say, all right, we know that here, therefore n must be greater than 15, right? Which tells us that n is itself equal to 16, because we are saying n is an element of natural numbers. So that next one is going to be 16, because 15 is at 0, meaning it gives us 330. But let's check it out and say, fine, if we put 15 squared plus 7 into 15, I'm getting 330. All right, so it only gets greater than 330 when it is starting with 16, because I want the first term to have a value greater than 330. So that is how you can go about this one. But other people, they just say, when is Tn equal to 330, and solve that. Then you'll see that it's going to be 15. Then you know you want to go just one digit up, which is going to be 16. So you can do it that way also. All right, guys. So, substituting into the correct formula is important. Factorizing, the tool that you choose, and then the final answer usually is what is important here. Okay, not a problem. Let's move on. So we have question 3 upon us. Question 3 says the sum of the first n terms of an arithmetic sequence. What is important is that this is an AS, is given by Sn equals minus n squared plus 8n. Even if they didn't state that this was an AS, you would know very well that the sum, if the sum of the n terms of a sequence is quadratic, that should be an arithmetic sequence, right? Right. Now let's have a look here. It says calculate the sum of the first 15 terms. Okay, this is easy. 3.1.1. So we're going to say S15 is going to be equal to minus 15 squared plus 8 into 15. So what is that? So minus into 15 squared plus 8 into 15. So I'm getting a minus 105. So this one is as good as correct substitution and the answer. Okay. 3.1.2. It says calculate the value of T15. I think I have taught this one very well in my lessons. As very boring as they look, they're not attractive at all. So I don't blame you guys for not watching them, but the idea is there is everything that you need to handle exams successfully there. So I would advise you to watch those videos, as not so interesting as they look. Anyway, calculate the value of T15. I know that Tn, when I'm given Sn formula, it's going to be S15, which is exactly what I want. Let's start by saying S is going to be Sn minus Sn minus 1. Okay. It's always like that. All right, so I taught this very well there, so I would truly advise you to go and have a look if you are not already aware of this. So this means T15 is going to be S15 minus S14. Okay, S15 already sorted it above is minus 105 minus into, okay, maybe let's put a big bracket here because we're going to have to substitute there. It's going to be minus into 14 squared plus 8 into 14. Then we close this, and then of course I can just pull it at a go. So what is that? Let's just sort this one out. Say minus 105 minus, and then sort this out. So this is minus into 14 squared plus 8 into 14. So I'm getting a minus 84. So you can already see here that when it times by negative, it becomes a plus 84. So it's minus 105 plus 84. Is that true? So it says minus 21. Okay, not a problem. Not a problem. Icon, as you know, the things I'm doing here, I don't know. Yeah, it's minus 21. All right, guys, so this is it. I mean, it makes logical sense. If you add 15 terms and then you're getting 105, then you add 14 terms, you're getting this number minus 84. It only makes sense that if you add one extra term, you will get to this 105. So 14, you add one last term, it goes to the sum of 15 terms. So that already tells us that the difference gives us that T15. Okay, not a problem. So here you are getting 2 marks again. So correct substitution, and the answer is how those marks come by. Okay, let's do the last question here. Do I have enough space? I actually do have plenty of space. Okay, so I can play around a bit if I want. So this is 3.1.3. It says now if the first term of the sequence is 7, okay, now they're giving us T1. So T1 is 7. Now which term of the sequence will have the value of minus 169? Okay, so we know that we will need the common difference, right? Yeah, man. We know that Tn is equal to A plus n minus 1 times D. Okay, we already know that, well, T15 is 21. Sorry, minus 21. So we know here that minus 21 is equal to A. They told us is 7. This is 15 minus 1 multiplied by D, which is what we want. Okay, this implies here when we sort this out, so let's say minus 21 equals, in fact I could easily divide by 7 already so that I avoid unnecessary multiplications. So if I divide by 7 here, it's going to be minus 3 is equal to 15D. Sorry, not 15D, but 14D. Okay. So what is the story? Highway. Something is not making sense. Yeah, I made an error. You can't divide by 3 because there's a plus in there. So my plus is missing here. There is actually a plus, so that was incorrect. So we move this guy to that side. So we get a minus 28 is equal to 14D, okay? Therefore, D is going to be a minus 2. So this is fine. So we are saying, therefore, this implies that Tn is equal to minus what? What is the value there? 169. Which implies that we're just going to go ahead. A is 7 plus n minus 1, which we don't know, into minus 2 must be minus 169. Okay, then we transpose this, and maybe let's put this one in the bracket so that it doesn't confuse somebody. And then let us sort this out. This implies that minus 2n plus 2 is equal to, when we add 7 there, we're getting a minus 176. Okay, and then of course we're going to add a2 as well, so minus 2n is equal to minus 2 there, we get a minus 178. Therefore n is going to be, we divide by minus 2 there, is 89. Okay, we can say therefore T89 is equal to minus 169. Okay, hope that is clear, guys. Of course there can be a lot of errors that can come by here if one is not careful, but I think if you have the approach, everything should pretty much be good. Okay, so let's go, guys. Sometimes it's pointless to try and map out where the marks are. If you do the right thing, you will win. Of course, let's just do it. Substitution here, getting this term, getting our common difference here, and then of course substituting into the correct formula. How many marks are they offering there? 4 marks. Yeah, looks like it. All right, let's keep moving, guys. So 3.2 says the first two terms of a geometric series are these ones. So already told what we're dealing with. So now it says determine the values of p for which the series will converge. So we know that for a convergent series, what do we need? Our r needs to be between 1 and minus 1. So let's sort out r. So r is going to be equal to 10 into 1 minus p over 3 squared divided by 5 into 1 minus p over 3. Okay, so we know that this one will take that, and then this one goes there. So our r here is 2 into 1 minus p over 3. Okay, that's it. So we can say here, for a convergent GS, it is such that r is less than 1, greater than minus 1. Okay, so how do we deal with this one? This implies now we put our r2 into 1 minus p over 3 should be less than 1, greater than minus 1. Okay, we divide by 2 throughout, we get minus a half is less than 1 minus p over 3. Same story there. And then we cross multiply by 3, so we get here minus 3 over 2 less than 1 minus p less than 3 over 2 on this side. Okay, so we transpose 1. When we transpose 1, what do we get? It looks like I'm gonna run out of space. When we transpose 1 here, we get minus 5 over 2 is less than minus p, which is itself less than, again, when we take 1 this side, we get a half. Okay, so therefore our p must be less than, so when we divide by negative, the signs changes, so it becomes 5 over 2 here. Yeah, let me just write it. Okay, greater than minus a half, because that one becomes a negative. So that is sorted. Of course, you solve for r here and then get 2 marks for this format. That is how you get your 3 marks. Easy stuff. Great. Okay, guys, let's keep moving. Now 3.3 says consider the series sine 30 degrees plus cos squared 60 degrees plus x degrees over 2 cubed. You see, that one is a problem. It's just there to cause you pain. But let's look at this question. Calculate the values of sum infinity minus S5. So do you see the key here is knowing that if you can get a sum to infinity. So what is this? This is literally AGS, okay? So we already know that this tells us that R is going to be cos squared 60 degrees divided by sine 30 degrees. Okay, how do I know there's going to be an R? Because if you can do a sum to infinity, this is a convergent geometric series. Okay, so that is the key, because you wouldn't know what you're dealing with when it's like that because of this guy over here. Okay, anyway, we continue doing our thing. We know that this is basically a half squared divided by another half. Okay, so this is the same as 1 over 4 times 2 over 1. And this is basically a half. So R is a half in here. Okay, we have enough space to play. So this implies that sum to infinity minus S5 is going to be something like this. Sum to infinity is A. We can already tell that sine 30 is a half. So we're going to have a, okay, let's just write the formulae. 1 minus R minus A into, remember R is less than 1, so we're going to use this one. Okay, not a problem. So A is a half. Divide by 1 minus a half. Okay, minus a half into, let's put big ones, 1 minus a half. This is 5, right? Raised to the exponent 5. Okay, so not a problem, over 1 minus a half. Okay guys, this is cool. So at times you just want to be a little bit careful. So this is a half divided by half, which is basically going to give us 1 minus, let's sort this one out, 0.5 into 1 minus 0.5 raised to the exponent 5. All right, divide by 0.5. So let's see, I'm getting here 31 over 32. So of course you multiply 32 there and then you subtract 31. So this is basically 1 over 32. Okay, and let's just double check. You know, sometimes certain things look too easy and only to find problems awaiting you on the other side. Yeah, it's 1 over 32, so it looks all right for me. Okay guys, let's finish this thing here. So of course here solving for R is important. They are giving 5 marks here. I think this substitution and that substitution is correct, and then the answer there is correct. The rest is mathematical gymnastics, but what is important to get us the extra mark is this convergence here of cos 60 degrees over sine 30 degrees. Okay, so this is how you can handle that. So let's quickly get to question 4, which is my favorite section, functions. So guys, this is where you want to make sure, because these are where the most of the marks are. You can actually pass this paper if you get total in functions and fail everything else, which is unlikely, you know. All right, so let's look at 4.1. So what is the story here? We're given f of x equals minus 2 over x minus 1 plus 2. So already here we know that our a is less than 0. So what does that tell us? It tells us that our graph is basically in the second quadrant and fourth quadrants, right? But it is shifted around, so we will expect that this graph is flying there some 2 units, and of course this horizontal asymptote as well is on this side somewhere. So we're expecting something that is shifted, but that represents where these quadrants would be because of the characteristics of A. Of course, I've taught a hyperbola in my lessons, so you can find it and make sure you learn as much as possible, because I can tell you all those videos where I did some lessons, they're structured to handle any question in mathematics that you can possibly get. Okay, so we don't want to waste time. We just keep going. So the question says here, write down the equation of the asymptotes of f. Okay, first of all, we take what is on the denominator, we equate it to 0, so x is going to be equal to 1, and then y is just that value of q as it appears. So those are the equations of the asymptotes. Okay, you get your 2 marks, 1 mark for each. So 4.2 says determine the coordinates of the x-intercept. So you know that for x-intercept, what happens? It implies that y is equal to 0. Okay, maybe let's do it this way. Sometimes, so this is such that y is equal to 0, so that we can save a bit of space. This implies here that 0 is equal to minus 2 over x minus 1 plus 2, which also implies that minus 2 over 1 is equal to minus 2 over x minus 1. This juncture you cross multiply, a technique you're already familiar with. Okay, I have enough space to work this out. This implies there that my 2x plus 2 is equal to minus 2, which also follows that minus 2x is equal to minus 4. Therefore, x is a 2. Okay, so what is the question? Is the x-intercept. So therefore, the x-intercept is such that 2 is to 0. Great stuff. All right, that is sorted. How many marks are they giving there? 3 marks, of course. That situation is important, and then of course you get your 2 marks here. The rest is mathematical gymnastics you are already familiar with. All right, so it says sketch the graph of f, clearly show all intercepts with x's as well as the asymptotes. So you already know here we only have an x-intercept. So we will definitely need the y-intercept. It is such that x is equal to 0. This implies that f at 0 is equal to minus 2 over 0 minus 1 plus 2, so which is exactly 4. All right, so we can say therefore the y-intercept is such that 0 is to 4. I think once we've sorted that, we can now sketch our graph. Okay, so we know that we're going to need 4. Okay, and then we need 2. That becomes our asymptote. Okay, and then our other asymptote is at 1. Okay, maybe let's not write it there, but let's just first put our asymptote. So it's gonna be a small sketch, guys. There is nothing I can do. I chout space here, which I think I should not. Okay, let's try and redeem ourselves here. Let's try and redeem ourselves. Okay, let's just redo this whole thing. Let's do this. I'm just moving it around so that I can have space. Okay. All right, so we just wanted to create a bit of working space here so that we can do our thing nicely. Okay, so now we're going to handle it like so. Okay, so let's first draw our asymptotes, because I think if we don't sort them out, it will lead to this graph sorting us out, and we don't like that. Okay, so basically we have that point over there. So if this is a 2, this must be a 4 somewhere here. And then if this is a 1, this is a 2 there, this is a 1. Okay, let's just write it here and say x is equal to 1, and probably yeah, write this one that y is equal to 2. So you always have to label the axis of symmetry, otherwise it becomes a bit of a painful exercise. This is 1, so this is a 2 here. So we can write our 2, we can write our 4, and then we draw the graph. So our graph cuts and cuts, and then of course we already know the shape from studying the characteristics of our graph. So our graph is doing this. Okay, so the other thing is that it's doing this. Spare that it looks a bit small. It's not a big deal. So that is this graph of f. And then of course we can label it and say this is f. Okay, so we've done everything that we were asked here. We've shown the asymptotes where they meet. Maybe we can write their numbers now. So this one is 1, that one was 4. Can write this one here as 2. And yeah, that is sorted. We've indicated everything. Of course, the origin needs to show up as such. Okay, guys, that is basically showing the intercepts, the shape, and the asymptotes. So that is standard 3 marks. Okay. Now the next question says, a graph of h is a straight line, okay, that passes through the point of intersection of the asymptotes of f, and then the angle of inclination is actually 135. So what does this tell us? It tells us that, well, we're looking at something that passes there. So this line, what we are being told is that its angle of inclination here is 135. Okay, so maybe my 135 is not really visible here, so it's 135 degrees. Okay, not a problem. So let us see, what do we know? Okay, it says now determine the equation of the line in terms of h of x, in the form h of x equals mx plus c. Okay, so we can just first say the gradient of h is going to be equal to the tangent of 135 degrees, right? Which is basically minus 1. Now we know if this passes through the point of intersections of our asymptotes and it has a gradient of 1. Okay, so this is basically an axis of symmetry of our graph where x, the gradient is minus 1. So this implies that h of x is equal to minus x plus c. Then of course through the intersection of the asymptotes, this is 1 is to 2. It is such that 2 is equal to minus into 1 plus c. Therefore c is equal to 3. Okay, therefore h of x is equal to minus x plus 3. Sorted. Of course, one of you guys may have thought, well, look at this. This is an axis of symmetry. Of course, this is a key statement. First, you have to determine that gradient because it can be any value whatsoever depending on the angle of inclination. But now that we know the gradient is 1, we can already say that h of x is going to be equal to minus into x minus 1 plus 2. You just do it from the hyperbola already. So this is going to be minus x plus 1 plus 2, which is going to be minus x plus 3. Okay, so this one avoids trying to work out the equation the standard way, but again, these are the lessons I have given in that video when I was discussing the hyperbola, so you should be in a position to just gel in and understand where is this coming from, and this actually simplifies your life. All right, guys, let's keep going. We have finished an hour already. So 4.5 says show that f of x, again, when you're told show, is equal to minus f of x, so f of 1 over x minus f of x is equal to that expression there. So all you do here, you just take the left hand side and deal with it. So you say f of 1 over x minus f of x is going to be equal to, what was our hyperbola there? It is minus 2 over, here you just put 1 over x minus 1. You're going to sort that out, plus 2. Okay, minus again here. Maybe let's sort this one out. But do we really have to know? Just a round bracket is enough. Minus 2 over x minus 1 plus 2. Okay, that is as simple as that. Do we have enough space? It looks like we do. So this is equal to, then we deal with the situations. You have minus 2 over, when you deal with that bracket, you just take the x and multiply, then subtract. So this is the same as 1 minus x over x, okay? Yeah, and then this is plus 2 over 1, okay? Great stuff. And then when we sort this out, it's going to be a plus 2 over x minus 1 minus 2, okay? That is what happens. And then of course this is over 1, so we already have fractions, so this one is not done. When we sort this out nicely into a single fraction, it becomes minus 2x over 1 minus x, and then here we're going to have a plus 2 over 1 plus 2 over x minus 1 minus 2 over 1. Already these ones cancel. So what do we have? We have minus 2x over, we factorize this thing by taking out a negative, it becomes x minus 1 plus 2 over x minus 1. So we want them to look alike. And then of course we further solve this one. Negative divided by negative is a positive. Okay, now we're sorted. So they have the same common denominator. They have the same denominator, sorry, that becomes a common denominator, which is x minus 1 over here. And then we simply have 2x plus 2. Then if we further factorize here by taking out the highest common factor in the numerator, it becomes 2 into x plus 1 all over x minus 1, which is equal to the right hand side. So we've shown it, so we're not going to bother ourselves with a lot of things here. All we did was just to do mathematics. All right, now let's look at question 5. It says here the graphs of h of x. Of course, we are given a parabola in the factorized form, the turning point form, sorry. What are you doing? What are you trying to do? You're trying to get me killed now. So that one, we already know that this is the turning point form. And obviously, looking at the graph itself directly, it is the grumpy face, okay? So if it is the grumpy face, we already know that our a should be equal to a negative number. So we actually say a is less than 0. So whenever we solve for a, we expect a negative number. If we don't, then that is incorrect. Otherwise, we also know the turning point coordinates. So this is them at E1:2, okay, which is fine. Is there anything else? We know that if this is 0, the origin, what would be the coordinates of D? Remember, this is 1 unit, then it's going to go 1 unit. So this is 2:0, with the origin being 0 and 0, okay? So we have those coordinates already doing us a big favor. And then we already know that at F we have 1 and 0, right? Because that is where the axis of symmetry cuts the x-axis. All right, so this is about it. And then we're told here we have g of x equals mx plus c, okay? This g of x, unfortunately, we don't have enough information at this point to say a lot. But we know that its x-intercept is f. That's all we know so far. And then we know that, okay, O, the origin, and D are the x-intercepts of H, okay, already telling us, and E is the turning point of H, okay. We've already established that E of ours there. We already saw it, okay. And then what is the next story? F is the x-intercept of G. Yeah, it is evident. And the line EF is perpendicular to the x-axis. Again, this is just to further say that the x-coordinate at E is the same as the x-coordinate at F, okay. P is the y-intercept of G. We can see that, not a problem. But remember, these statements are very important, guys. Keep them in mind. Okay, so let's quickly answer these questions. Write down the coordinates of F, okay. So 5.1, when they say write down, we can already tell that if this line is perpendicular to the x-axis, it means the x-coordinate at F is the same as the x-coordinate at E. So again, they said write down, so you don't want to explain. You can just write F is the point 1:0. You leave it like that. But if they said determine, you would then have to explain by using that piece of information. So 5.2 says, if OP is 3 units, determine the equation, okay? Determine the equation of g of x in the form g of x equals mx plus c. That's not a problem. What can we do here? We can say OP is 3 units. Okay, that is given. Remember, when they say determine, you need to show us the logic behind what you're saying. Therefore, we know that P is going to be 0 is to minus 3. That is critical. I mean, we are on the negative axis, so that is logical, okay? It's just a logical explanation, okay? I think we have a bit of space to work. So what does this tell us? It tells us, therefore, that the gradient of G is going to be, let's take this point P as the first point. It's going to be minus 3 minus 0 at F, okay? Divide by this 0 minus 1 at F, which is basically minus 3. Okay, let's just write it there, which is basically 3. Okay, it's a positive gradient. It makes sense. We can say, well, the y-intercept, already they told us P is the y-intercept. The y-intercept of G is equal to minus 3. Therefore, G of x is equal to 3x minus 3. That's it. It's done. Okay, so that was just 2 marks to find the gradient and to find the equation, because everything was pretty implied. Okay, 5.3. What is the story here? It says show that the equation of h is h of x equals minus 2x squared plus 4x. Okay, not a problem. First of all, we know that h of x is equal to a into x minus 1 all squared plus 2. That's what we're given. And then, of course, through the origin, we know that 0 is going to be equal to a into 0 minus 1 all squared plus 2. We need to solve for a here. And then I can solve for a already in the very quickest of ways. I know that this is going to be a is equal to minus 2 basically. Done. And it's a negative number. So this implies that h of x is equal to minus 2 into x minus 1 all squared plus 2. Then we follow this out. X squared minus 2x plus 1 plus 2. Then we have minus 2x squared plus 4x minus 2 plus 2. And those ones already do a number to each other. We have minus 2x squared plus 4x. And that's exactly what they wanted us to show. So important is to solve for a here, and then the correct substitution and the final answer. That's how the 3 marks come about. Then the next one says, looks like we're gonna run out of space here. This is dangerous. It's dangerous. Why didn't I give myself enough space here? 5.4. I don't know why. Anyway, so let's solve this one. It says determine the equation of the tangent to h at D. So we can first start by saying D is the point 2 is to 0. Of course, we're using the axis of symmetry here. Or you can decide to factorize here. When you factorize here, you're going to take out the highest common factor, which is minus 2x. It's going to be into x minus 2. And then you can see that the other bracket is going to be that. So, I mean, you don't have to overly explain when things are pretty obvious. And then, of course, we know that, well, the gradient of, what did they say, of the tangent is equal to the first derivative, sorry, not f, but this is h, is going to be h at 2. Or you can say x at D, which is fine. When we do the derivative here, we get a minus 4 into 2 plus 4. What is that? This is minus 8 plus 4, which is minus 4, okay? Then we can say, therefore, the tangent is such that y is equal to, okay, let's say it implies that the tangent is y equals to minus 4x plus c. Say through point D, which is 2 is to 0. Remember, it's still an important point. 0 is minus 4 into 2 plus c. Therefore, our c is, this is minus 8. It becomes 8. Therefore, y is equal to minus 4x plus 8. Does it make sense? Of course it does, because if we draw a tangent line here, it will have a negative gradient, right? And it will cut on the positive y-axis, so it makes a whole lot of sense. So how many marks were we getting there? 4 marks. Okay. Obviously, finding the coordinates of D is critical here, and then of course doing the derivative here is important, and then getting the y-intercept in the final equation. Okay, that is how that is handled. Sorry. What is the last question? Okay, last question says points O, E, D, and P. Okay, maybe let's remove all of these things now. They're going to cause us problems. Let's choose a color there. So O, E, D, and P are joined to form a quadrilateral. Okay, let's see. Let us see, what can we do here? Where is my thingy? I want to be able to do this shape seesaw. Now, let's see here. We're saying this to that. I wait. What is that now? Icon. You see now this thing is doing its own things. ingijwayela kabi. Okay guys, looks like we're in trouble a little bit, but let's sort it out. Okay, what we're going to do here, we're just going to try and join this thing. I don't know why it refuses. Come on man, do this thing, man. Okay, it refuses to do the thing that it must do. I'm just going to do my thing on my own then. So there's our quadrilateral. Okay, it almost became perfect, but yeah, that thing just refused to work. I don't know why. Try laga. Anyway, let's leave it alone and it's nonsense for now. We just have to focus on the squad. What do they want with the squad? They want us to determine the area of this quadrilateral. So look, divide this quadrilateral into two. You can already see that that is perpendicular height, and then we already know the coordinates at D. This is 2 and 0. So we know that this is going to be 2 units. OD is 2 units. FE is going to be 2 units. And then of course this is also like that, and we already know here we have 0 and minus 3. Okay, so you divide it into two quadrilaterals, then triangles, then we can actually sort it out nicely. Okay, let's do this one. So we can say here 5.5. I don't know why are you trying to disappear. Thing is, okay, so we have here 5.5. So we can say area of O, what is that? OEDP is going to be equal to half. Let's just write the names. It's gonna be half OD. It's gonna be half OD. I win. Get low sharp, right? Get low sharp. Warning, you are not invited into this party thing. Half OD multiplied by, just gonna try and run this one FE plus, this is the same again as half OD multiplied by this time OP. Okay, I'm just messing up a little bit, times OP. Okay, this is equal to half into OD. We got 2 units, and then FE was 2 units, plus half OD is the common base, right? It's 2 units. This time it's 3 units, and then of course 2 cancels 2 there, and then 2 cancels 2 there. So this is basically 2 plus 3, which is 5 units squared. All right, so this is as easy as that, guys. So this is how you work out function related questions. Pretty nice, isn't it? Yes, man. So answer is important, and I think this substitution and that substitution is pretty heavy. Okay, let's do the last one here. So yeah, hey, functions can take a toll on a person, right? So we're given g of x. So g of x is an exponential function. Again, look at a. A is greater than 0 because it's a positive number, which is just 1. So this is not a shifted graph, so we expect our graph to be, okay, before we get to the shape, all we know is that when a is greater than 0, it appears above the horizontal asymptote, which is basically the x-axis, okay? And then let's look at b. B itself is greater than 0. Remember, b represents the base of that power. And then what is the story? Then it means this is an increasing function. So we're expecting something like that. Okay, always keep this in mind. It can save your life, believe me. All right, so this is fine. And then 6.1 says write down the equation of the inverse of g. So 6.1 in the form. So we know that, well, y is going to be equal to the log of x to the base. Oops, where did I get the 4? To the base 2. Now, if you don't remember this, folks, there's plenty of videos on the platform. Both my videos, I've discussed these exponential functions and their inverses, which is the log functions. I have a separate lesson for this. I also have been doing past exam question papers and truly working it out nicely. So this should already be second nature. But if it is not, please do have a look on how this is done. We're just trying to save time this time. You will see that once you get things in order, you are able to save a lot of time when you are dealing with these kinds of questions. All right, let's have a look here. The question says sketch the graph of the inverse, okay, showing clearly all the intercepts with the x's and a point on the graph. Okay, so that is important. Okay, well, we know that the inverse of x is given by log of x to the base 2. All right, so already here you don't want to stress yourself a lot. You just go ahead. You look at yourself and say, well, my base is a 2, so it's a base that is greater than 1. And the base cannot be 1, by the way, so it is greater than 1, so it's an increasing function basically, because the original is also an increasing function. So this is an increasing function. So we're going to just jump in and sort it out. And then, why do I want to say that? I must not say too many things, man. Akho kuhle ngwana ntate. Of course, always show the axis. Okay, the y-axis, the x-axis, and the origin is very important. But all I know is that, well, what do I know? I know that the issue is x cannot be 0. So meaning it will not have a y-intercept. But it does have an x-intercept. Yes, so the x-intercept is at 1. Okay, so this is how the graph will look. Okay, so this is the graph of the inverse. Okay, no problem. So it's done. So there's the x-intercept is shown, and then of course we were told to show one other point. So we can choose this point when this is 2. This is effectively going to be 1. So if you do that, you are sorted, or you can name that point A if you like, and then write the coordinates. It's fine, not a problem. So this is as simple as that. Okay, so that is fine. You get the marks for doing what you were asked to do. So this is pretty easy. And then it says use your graph. Now use your graph to determine the values of x for which for which the inverse is less than 1, greater than 0. So when is that? Thankfully, I chose it. You could have chosen any other point, but I conveniently chose this one because guess what? It is 1 at 2. So this means this is the region that I'm looking for, because here it is 0 at 1. So 1 is not included. So it is greater than 0. And it is less than 1. So this is basically our feasible region that we're looking for. So let's answer this question of 6.3. We know that x must be less than 2, must be greater than 1. You get 2 marks for that format. So you see with the graph it becomes easier to see what is going on. So 6.4, now it says h of x is equal, if h of x is equal to A half raised to the exponent x. Describe the transformation of from, okay, now this transformation needs to track from the inverse of g, okay? So now remember, we essentially are going to end up with something like that. If you look at it, h of x is a half raised to the exponent x, which is 2 to the minus x, basically. So if you look at that, how can we track what we've done here? Yo, I've given myself a lot of space for nothing. Hey, when okay, so basically this implies that, well, h is there. I'm gonna try to write well. Is the graph of the inverse of g that is reflected about the line y equals to x, okay? Because remember, we will have this line, the inverse line, which is y is equal to x, okay? So if we reflect this graph, we get the original, which is something like that, okay? It will cut at 1 and do its thing. Okay, so first of all, we're going to have to do that. But the final one is still going to be reflected further, because we know that once this graph is like that, we have our base. Remember, this base is much better when you show it like that. If it is a half, and we know that our a is greater than 0, it means we will have a decreasing function. So this graph is eventually going to be something like this. Okay. So it's going to be something like that. Of course, you don't have to draw these things. I'm just drawing so that you can understand the logic behind this explanation. So basically, we first take an inverse of this inverse first, and then that very inverse we reflect it about the y-axis. This is how it looks like. Okay, I've discussed again all of these reflections of these graphs when I discussed the exponential graph together with the log graph. So what do we have here? We can say now we essentially reflected the graph of g about the line y equal to x. This is an inverse line, so it's important. This is very important. So it's one of the key elements of this explanation. Okay, reflected about the line y equal to x, and then further reflected about the y-axis. Okay, to obtain the graph of h. So basically we've explained ourselves. So there's two reflections here that we've performed. We first reflected our graph about the line y equals x, which is its inverse. That very inverse, we further reflected it on the y-axis. As you know, you simply multiply the x values by a minus 2 when you're doing a horizontal reflection. Alright guys, this is how you can explain this. Of course, this tracks back from all of those flip-flops that we've had to do. So easy questions there. So you get a mark for the first reflection and then the mark for the second reflection. So that is good. Alright guys, let's get to the money. The mullahs. Lerato won 35,000 in a competition. She invests the money in an account at an interest rate of 9% per annum compounded quarterly, which is not really a smart move, I can tell you. But because you don't know, you are all told that investments actually work. Well, they work for the banks, but wait. They don't work for you. You're not going to make money. You're going to lose money. So don't be silly. Lerato, I know the idea is good on paper, but in reality, those people rip us apart, okay? So you have to be smarter than that, okay? You'd rather do something that can generate more money on this, and then you can save. Otherwise, you're going to lose a lot of this money. Okay, anyway, it depends on what type of an investment you took again, so it's fine. Well, this is compounded quarterly, so this is important. Quarterly. That says calculate how much interest Lerato earned. What do we want? Interest that Lerato earned at the end of how long a period? 6 years. All right, this is a pretty straightforward compound interest type of a question. 7.1, we will answer it like so. So we know that, well, A is equal to P into 1 plus I to the exponent n. First of all, we need to know how much money she accumulated, right? So this is from 35,000 into 1 plus, what is our I there? I is 0.09, but this is quarterly, so we do the nominal interest. Then for 6 years, so this is 6 times 4. Okay, I don't know why it doesn't want to show. Hey, when a man scantina, when a man scantina, when a man. Why it's so let's just do that one first. 35 gorillas. Is it gorillas? No, it's Gordos. This one is 35 Gordo into 1 plus 0.09 over 4, you know. Ke ngwana tsotse monna ke hlaya di township nkwana. I'm from the urban, is it urban areas? Yeah, I spent some time in the urban areas, so I know a bit of Tsotsital there. I know a bit of Tsotsital, so this is going to be that one. So what I'm getting here is a 59,701 rands 83 cents. Okay, so this is the accumulated amount. Okay, so we can say this implies that interest and interest and, okay, by Lerato is equal to this amount here, which is our A value minus our original amount. Okay, that is easy, ne? So this is 59,701.83 cents minus 35,000. 35 decent. Let's take out the 35 score door. This tells us that she earned an interest of 24,701 rands 83 cents. Okay, that's quite a lot, but think about it, man. 6 years, you only got 24,000, not even double the amount. So long a time. The child is born and is able to talk and converse. Do you see how very ineffective these things are? But anyway, time flies though. You would feel like it hasn't been 6 years at all, but yeah, this is just a clear depiction of how horrible it is that our investments really don't make money for us, but they make money for the banks, you know? I mean, this is ridiculous. You should have doubled at least this amount at that time. It's quite a long time, right? Right, but anyway, they don't serve the purpose of growing our money. They grow their own money. Look at this. 9%. I mean, you'll hardly find a bank that gives you this much percentage on your investments or whatever. You will get far less, like 4. It's even worse now. You're getting 4, 2, 3, like absolutely nothing. And the worst thing is, you lose more. Anyway, I'm not going to pump negativity into you guys. But it's just the sad reality, though, that as good as this thing sounds on paper, it's ridiculous in reality. Anyway, so that was how many marks we're trying to get. The 3 marks. Of course, the most important is to get this guy, and then, of course, substitution there, and then this final answer. Ne? Easy marks. Easy marks, easy marks. All right. Now let's look at 7.2. 7.2 says the price of a car depreciates at a rate of 12%. Okay, that is the per annum on a reducing balance method. Okay, so this question is pretty famous, so expect it in your finals. After 4 years, okay, that's the time period, the value of the car is 56,000 rands. Determine the original price. Okay, easy stuff. So we know that A is going to be equal to P into 1 minus I to the exponent n. Remember, this is the reducing balance method. Of course, our A is our last amount, which is 56 square into P, which we are looking for, 1 minus the I. Here you express it as a percentage, so this is 0.12. And then, of course, this is per annum, so there's no quarters or anything, so this is just to the exponent 4. Simple. Therefore, P is going to be 56 square there, divide by 1 minus 0.12 to the exponent 4. Let's see how much molar it was. So 56,000 divide, oops, what am I doing? Divide by 1 minus 0.12 to the exponent 4. Hey, so this says we had 93,308 rands 75 cents. Okay, so that is it. Okay, again, easy calculation, nothing major there. So basically you will be awarded marks for this general substitution, and then maybe 2 marks for the answer. I don't know, nothing is really special here, nothing is special. Okay, so we move on. Now we are told here a company wants to buy a minibus in 5 years time. So that is the time frame we're aiming to do this purchase. The expected cost of the new minibus is 85,000 squares. Now, what amount of money should the company deposit at the end of every month? Okay, pay attention to the statements given, end of every month. Okay, into a savings account. So once you hear the word savings, you know, dealing with some future value situation here. That pays interest at 8% per annum, compounded monthly. Okay, the period of compounding is important. In order to have enough money to buy the minibus, again, they're repeating the 5 years. They already told us on the opening statement. Of course, guys, what is important here? Timelines. This cannot be overly emphasized, Bafuet. T0, there's nothing there. T1, we're paying this X amount. This is what we want to find out. And then T2, we're paying our X amount. And then it goes on to Tn. Okay, maybe let's just solve. This is 5 years compounded monthly. So n is basically going to be 12 by 5, which is 60. So this is T60, this is T59. We're still paying the X amount, And then, of course, if we look at our percentage is what? 8% per annum monthly. Okay, so once I have reminded myself of what I need to do, it always makes my life easy. So we know here, well, we want to know how much amount of money. So we know that the future value formula is x into 1 plus I to the exponent n minus 1 all over I. So this follows that, okay, maybe let's not even follows, we can even make a conclusion. Therefore, x is going to be the future value multiplied by I over this expression here, 1 plus I to the exponent n minus 1. We do the correct substitution. We have 850,000 into, now we sort this out, it's going to be 0, why is everything looking like? So this is going to be 0,08 over 12. All of that divide by 1 plus 0,08 divide by 12 to the exponent 60 minus 1. Okay, so how many runs? How many runs or rands? Is it rands or runs? Oh, whatever. 850 squared into 0,08 divided by 12 over 1 plus 0,08 over 12, that raised to the exponent 60 minus 1. We close the bracket. So I'm getting a value of 11,568 rands at 27 cents to 2 decimal places. Okay, this is pretty straightforward. No issues. Okay, of course, here the 3 marks come from, I would suppose, getting the nominal interest here. Also, the period is important. Yeah, it's quite technical. So 1 mark, we say general substitution, just putting everything where it's supposed to be. Then we can decide whether we're giving half for the nominal interest and then half for the period to make up the 3rd mark. Doesn't matter, honestly. You already know how this thing is done. Okay, that was easy, 3 marks. Then we are told here, the chairperson, sometimes these people can be out of order, of the board suggests that a loan, see now they're causing us to lose money, should be taken to buy the minibus. Okay, the interest on the loan is, now do you see the interest is a lot when it's for the bank, but it's little when it's yours. You see how silly these people are. Crazy things. Of course, compounded monthly. Okay, not a problem. Repayments will commence in exactly 1 month after the loan is granted. Okay, so you start paying a month later. So these are some of the areas you need to get used to. Determine how many installments. Okay, this basically tells us we need to calculate the period within which we can pay off this amount of money. Okay, let's see. I'm saying a lot of things at once. Determine how many installments need to be paid in the same amount. If the same amount that they would have saved each month becomes the monthly installment. Okay, so that means this amount up here becomes what we are willing to pay each month. Okay, so let's have a look at this question. Again, it demands a timeline. I know you guys may probably not like this timeline business, but I like it. So we're taking 850,000. And then T1, we are paying 11,568 rands, 27 cents. And then, of course, T2, we're doing the same. 11,000. 568.27 cents, and then of course here this is Tn minus 1, this is Tn, which is what we want. We're paying the same amount. Okay, all right, okay. Okay, bafowethu asenzeni lapha. This is 8.5% per annum monthly. Okay, all right, what is that? We are using the blue. Okay guys, so what do we do here now? The question is, how long will it take? This is a present value formula, right? So present value is going to be x into 1 minus 1 plus I to the exponent minus n all over I. Okay, know this off by heart, but if you're really struggling, go and check in the information sheet, but that is a waste of time. You already need to know a lot of this by heart and make sure you know them well. But of course, to not make mistakes, just double check in case you're not sure. Here I'm gonna be quick, guys. What I want is n, so I know here that my n is gonna be minus the log of what? This multiplies the divide by x and taken from 1. So this is going to be 1 minus p times I over x, okay? That is what I know. And then the base here is going to be that expression 1 plus I. So if you don't know the mathematical gymnastics that landed us down here, please do make sure you watch the previous video where I did the Mpumalanga paper. I did try to show exactly how we arrive at this, okay? Right now, you just want to make sure you cut as many corners as possible, but in a very nice way, okay? This is equal to minus log, okay? Log of what? Of this one. 1 minus, our value there was 850,000 multiplied by 0,085 over 12. Okay, all of that divide by our 11,568,27. Okay, close that bracket. It's quite hectic, eh? To the base of 1 plus 0,085 over 12. Okay, now we can sort it out. Say what is our answer there. So let's go for it. Easy stuff, eh? Now go minus log. See, again, we have fancy calculators that do a lot of fancy things for us. 0,085 over 12. We close bracket and then we go there 1 minus. This one is 850,000. Please, guys, make sure your substitutions are on point, okay? It can be horrible if those are not on point. It will bring tears to somebody. Okay, so 11,568,27. So bafowethu, what is the verdict? It's 104. Yeah. It's 104. Of course, it says comma 1, 2, whatever. So that is telling us about, if this is months, it's going to tell us about weeks. So we don't really care. At this point, our Tn is a natural number. So we want 104. We want a round number. We can't have a decimal, right? Right. But this already tells us if we have a decimal, it means this money is not going to be complete. There's going to be a small amount left to pay finally. Maybe we can add on top to settle the thing. Okay, guys, so this is fine. Calculating the period needs you to apply logs. All right. How many marks here were we aiming for? This is just 4 marks. Okay. Sorry. We're getting a mark here. And then this whole lovely substitution is important. And nominal interest is important. I think the mathematical gymnastic here of doing logs is also important. So this is how we get the 4 marks. Okay. That's easy. We just move on. Then now they say, what will be the outstanding balance in the loan immediately after the 104th payment? Which means it confirms we are correct about our calculation up there. Fine, the balance outstanding here, we know that there was a comma something. It tells us that we would not have paid in full that amount. In just 104, there will be something left. So let's find out. I prefer the future value formula for this. It makes a lot of sense for me. So we know that the balance outstanding, that B, why always that B looks like is hungry? Yeah, man, stop being hungry, man. You're being fed here. So basically, we're going to look at the compound interest on our loan itself. So it's going to be P into 1 plus I to the exponent n minus the future value of what we would have paid over the same period. Okay, so this is equal to, now this was 85,000 into 1 plus 0,085 over 12. Of course, this is to the 104. Okay, minus the future value here is 11,568,27 into, okay, not like that, but like this, 1 plus 0,085 over 12. Whew. Okay, so it's not really working out. It's not really working out, so we're just going to put it here. So this is going to be 11,568,27 into 1 plus 0,085 over 12, all to the 104 minus 1. Close it. And then all of it we divide it by 0,085 over 12. Okay, it's a bit complicated. Space became my enemy there. All right, so let's do it, folks. It's 850 squared to 1 plus 0,085 over 12. This is all raised to the exponent 104. I'm subtracting the future value of this 11,568,27 into 1 plus 0,085 over 12. That raised to the 104. Mine ay wena skatata shwela jwaling wena. This is a bracket, by the way. I don't know what is that trying to look like. 0,085 over 12. The only thing here, you need to be meticulous when it comes to your substitutions. Otherwise, the calculators already do you a very good favor. So this tells us we'll be left with 1,404 rands 17 cents. Okay, to 2 decimal places. Of course, this is sensible. You can tell it's a small amount than the amount would have paid every month. So this, we could easily just pay this much extra. Okay. All right, guys, this is how you crack those 3 marks. What is important is this guy and this guy and this guy. Okay. Now let's go to differential calculus, which is the easy part. Sometimes I feel like I should not do this part when I'm doing my videos, but for the sake of completeness, this is lim as h tends to 0 of f of x plus h minus f of x all over h. So this is Sir Isaac Newton's quotient, and I showed you how you derive it by using my parabola lesson. Okay, so you may want to go and have a look if you don't remember. So this is equal to the lim, what am I doing, as h tends to 0. So let's start doing the thing. So we're going to substitute. So we're going to have 4 minus 2. Where you see x, you put x plus h, and then it's going to be squared. And then, of course, minus f of x is the whole thing, is 4 minus 2x. Wait, what are you doing? All over h. This is equal to the lim. Iyantlwayela jwale. Nitayidlaya. So this is going to be 4 minus 2 into, expand this. This is x squared plus 2xh plus h squared. Okay, minus 4 plus 2x squared. Okay, over h. This is the limit as h tends to 0 of, we sort this out further. So we FOIL this one out, so it's going to be 4 minus 2x squared minus 4xh minus 2h squared minus 4 plus 2x over h. So if you guys here are going to start doing a number on each other nicely, yeah, something is not correct here. Please guys, make sure everything you write is correct, okay? But you will see when things don't cancel out here, there's a lot of cancellations that need to happen. If they don't happen, then you already know you are somewhere out there in the cold. So what we're left with here is minus 4xh minus 2h squared over h, okay? So we want to sort this out. Wow, I've given myself so much space. Oh, but this space will have to accommodate the other two differentiations. So let's be thorough here. So this is the limit as h tends to 0 of, we factorize it, the highest common factor here is just h. So we can take out minus h if we like, but I think h is better. So let's just take h, will remain with minus 4x minus 2h over h, and then these ones do a number on each other. Then we drop the limit. At this point we get minus 4x minus 2 into 0, which is just minus 4x. Okay, now again, you just do your power rule here. You know that this is going to be minus 4x, so this is correct. So you get your 6 marks. Okay, so next question, this is 8.2. Point 1, so we need to find the derivative of y in terms of x. So if we have y equals, this is x cubed minus 2 into x squared plus 1. Okay, so we simplify this. This is going to be x to the exponent 5. Right, rules of exponents, multiplying powers with the same basis, you simply add exponents. And then this is going to be plus x cubed minus 2x squared minus 2. So therefore we know that our dy over dx here is going to be equal to, now this is going to be 5x to the exponent 4 plus 3x squared minus 4x. And that's it, okay? You don't want to complicate your life, you leave it here. 8.2.2. The next one is that expression over there. So we want to find the derivative in terms of x. It's just another notation of expressing it. This is the square root of x cubed over 2 minus 5 over x squared, okay? Not a problem. So let's sort this out. This implies that the differentiation in terms of x, we just first sort this out. Never differentiate when you have square root signs or fractions. So this is going to be x, when you change this, is going to be 3 over 2. All right, minus here is going to be 5x to the minus 2. Okay, now we can use an equal sign. We're doing the actual differentiation. Is going to be 3 over 2x. When you subtract 1 here, is like that, plus 10x to the minus 3. Again, don't want to complicate your life, you want to leave it here, okay? Don't do it any further, it's dangerous. Okay guys, these marks are pretty easy. I'm not even going to bother you with where they are. We just want to go. Question 9. Given that f of x is x cubed minus 6x squared plus 9x minus 4. All right, now we can see that this is our standard cubic function with everything in there. So we just have to work it out. But what is important is that if you look at a is greater than 0, which tells us that our function is something like this. Okay, it's an increasing function with just the decreasing portion between the two turning points. Okay, now the question says write down the coordinates of the y-intercept of f. So 9.1, we can just say, well, the y-intercept is such that 0 is 2 minus 4. The y-intercept is always the constant, which is minus 4 there. Not a problem. So 9.2. Determine the values of x for which the first derivative of x is equal to 0. So basically this is an indirect way of saying find the x coordinates of the turning points. So we know that the first derivative being equal to 0 implies we derive there, it's going to be 3x squared minus 12x plus 9 is equal to 0. We can divide throughout by 3. This is x squared minus 4x plus 3 equal to 0. And then we can factorize this thing. This is x minus 3 minus 1. Right. So therefore x is equal to 1 or x is equal to 3. So it says determine the values of x for which the first derivative is 0, and that is it. Okay, so this is pretty straightforward, guys. No business to be discussed in there. Now it says determine the coordinates of the x-intercepts of f. Okay, let's start here. So 9.3. So what the coordinates of the x-intercepts of f. Okay, so of course we know that for x-intercepts it implies that y must be 0. This implies that x cubed minus 6x squared plus 9x minus 4 is equal to 0, which implies, now I can tell you, always try, once you've been asked to find the turning point, the x coordinates of the turning points, always try to replace this one into the original. That's another quick way of finding out, but sometimes it may not work. You may have to really do the searching, but this must be a clue. Try this one or that one and see what happens. So let's try a 1, for example. 1 cubed minus 6 into 1 squared plus 9 into 1 minus 4. I'm getting a 0, so definitely that means there is equal roots at x is equal to 1. So I already know that if 1 put into the original gives me 0, I'm going to have a situation where x minus 1 is a factor, and then I just have to factorize that by inspection. But you can use synthetic division. I've shown how it is done, as well as the remainder. What is this? Is it remainder theorem? Yeah, or long division. Let's have a look at this one. What do we do here? We just put the x squared because that must give us the x cubed. Always focus on the first term and the last term here. So minus 1 with what should give me 4 with a plus 4. Great. Now what should I have in here? So this is already x. This is 4x. So what must I have here to give me 9x? It must be a minus 5x, because if you have minus times minus, it's a plus 5x plus 4x, it gives me 9x, and it automatically will give me that because x times that is minus 5x squared, and then minus 1 times this one is minus x squared, that gives me minus 6x squared. So it is equal. This implies that x minus 1 into is equal to 0. I understand. Anyway, so we can further factorize this x, and then we can already tell here that both brackets this time are negative. Okay, so do you see there were equal roots indeed, because there we're going to have equal roots. We can say here, therefore, x is equal to 1, or x is equal to 4. We can say, therefore, the x-intercepts are such that we have 1 and 0. There's equal roots here, always indicate, so that you make up for what is missing, and 4 is to 0. Okay, so that is sorted, guys. So we've sorted the x-intercepts. Easy, 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 easy. Okay, I have a bit of space there. So now it says here, sketch the graph of f showing all the intercepts at the axis and the coordinates of the turning points. Okay, that we can handle easily. So before we can sketch, we need to find the coordinates of those turning points. We can already tell here that f of 1 is 0, so that turning point is already sorted. There's equal roots there, it's already a turning point. We need to find f at 4, which makes our lives a bit easy. So before we can sketch, so this is 9.4 dot 9.4. What do we want? We want f at 3, sorry, not 4, f at 3, because f at 4 is 0, ne? F at 3 is going to be equal to what? So let's see. We go to the original function here. So we're going to have 3 cubed minus 6 into 3 squared plus 9 into 3 minus 4. I'm getting a minus 4. Okay, so f of 3 is minus 4. Okay, so that's not a problem. Let me just double check. Is everything the way it is here? When yeah, it looks all right. So it's minus 4. Okay, so this is fine. So this other turning point is 3 is to minus 4, and then we can go and do the sketch now. So we know that our sketch is going to be something like this. So our x coordinate is 1, 2, 3, 4. Okay, let's just expand it just a little. This is 0. This is the y-axis. And then, of course, we know that the y-intercept is at minus 4. And one of the turning points is doing a number there. So this is 1, 2, 3, 4. Those values are important because we saw that when we determined our stuff, it turned out to do something like that. So it's cutting here, it's turning here, it's coming down, and then at 3, it is at minus 4 as well. So it's turning over there, and then it's cutting. So we already know the shape of our graph, right? We do. Yeah, when Scandina, when man. Scandina, when man. Okay, so this graph is doing something like this. All right. Of course, it's not gonna be exactly perfect, but you get the idea bafowethu. Mina ngiyazama njengegama lami nje kuphela. Akukho nje okunye. I just try. That's all. Which I would advise you to do as well. Always make sure you try. Okay, there it is. That's the one. So this is F. You can label it. That this is our F. And then, of course, make sure you indicate where this turning point is. It is at 3, ne? Or you can write the coordinates, but I always prefer to just leave things as they are. Okay, so this is what the sketch would look like. Okay, guys. Next question says, for which values of x is f concave up? Okay, you look at this graph easily and not cause yourself unnecessary problems. Not you, sir, but you. Okay, so, oh yeah, this question was already copied down here. Okay, not a problem. So my 9.5 here, when is it going to be concave up? It means I must find the point of inflection. And I'm looking for an x value. So this is the x coordinate at the point of inflection. Looking at this graph, I already know that that x coordinate is halfway between the x coordinate of the two turning points. So what is the story there? I know that here my x should be greater than. Why greater? Because it's already concave up beyond the point of inflection. Greater than, let's say, the first one is 1 plus the second one, which is 3 over 2. Therefore, x must be greater than 2. That means our point of inflection is essentially at 2. Okay? So from this point on, it's concave up, and from this point down, it is concave down. All right. Easy question. And then, of course, you could have looked at it in terms of the first derivative, just so that you can have a bit of a flavor there. We know that for a cubic function, say for f to be concave up, it is such that the second derivative of x is greater than 0. So you always deal with that from the theory like that. Now let's do, we saw that the first derivative gave us 3x squared minus 12x plus 9. So this implies that we're going to have now 6x minus 12 is greater than 0, right? Then you can already see here that x is going to be greater than 2 as well. So you can go about it this way. You can go about it that way by using the graph. It's entirely up to you. All right. Not a problem, guys. Then now the last question says, for which values of x is f of x equal to k? It's going to have 3 positive roots. So with a cubic function, you can't do the discriminant. It's impossible. Now, what you want to do is to use your math skills or function skills. So now, to answer this question, we are going to say, fine, k is technically a constant. So this means it's a horizontal line. So this horizontal line could be any line that is cutting here. So this could be k, but it can also cut here. This could still be our k. It can cut here. That is still k. Y is equal to k. It can cut there. Just looking for this region. It can cut over there. So this is still y equals k. Okay, so basically, where is the one that gives us what we want? We want 3 positive roots, meaning the points of intersection must be 3. Okay, so look at this one. It only intersects the graph once if we are below that 4. If we are at 4, it only intersects it twice. Okay, that's not 3. And then, of course, this is 0. It's not even positive, so there's only one positive root there. Here, it's a negative root. It's already out. But if it cuts here, it intersects there and there. So we have 2 positive roots, not 3. If above there, we only have 1 positive root, but look in between 0 and minus 4, it cuts 3 times. So this means our constraint is in this region for our k. So we can then answer this question with confidence that for 5.6, sorry, not 5.6, 9.6, we know that k must be less than 0 but greater than minus 4. Okay, so this is easy. So sometimes you just move this line, you make it mobile until it satisfies what is stated, or you basically move this graph up and down until you get 3 intercepts that are positive on that line. But it will boil down to the same explanation. Alright guys, this is cool, easy 16 marks. Then let's move on guys to our next question. Here, what do we have? Okay, so we are told here that the cost to transport an abnormal load, okay, we're dealing with cost for 1 hour. So the comparison is between the amount of money we want versus 1 hour is given by this formula. Okay, quite a complicated, it's quadratic. So it already tells you that this cost per hour, if you follow it as a sequence, it forms a quadratic sequence where you will have the first differences, second differences. And technically, if you look at this, it's similar to the question that the Gauteng guys got. They talked about the cost per room or renting a room, and that formed a quadratic sequence. So if you can try and find a way of complexing those two, you can actually solve that question pretty easily. Anyway, let's have a look at this one. So it's a quadratic sequence, so this is easy. Now it says where C is the cost per hour. Okay, great stuff, we know that. This is the cost per hour. They already told us in 1 hour. I don't know why they are saying this too much, but anyway, it's fine. And S is the average speed in kilometers per hour. I'm happy about that. And then of course it says now show that the total cost for a trip of 400 kilometers at an average speed of S kilometers per hour is given by that. All right, so what is important here guys is to know, if you're doing physics, you know that the displacement delta x is equal to delta what? V times delta t, ne? But here we're not going to be using physical science notations here. All that we know here is that the distance is going to be the speed multiplied by time. Okay, now we want to represent the time, because we already know that the kilometers, the distance is 400 kilometers, the speed is s. So we are sorted here. We know that therefore t is going to be basically d over s, which is 400 kilometers over s. It's as simple as that. Now we know that we're getting paid money per time, so this new situation will simply substitute into that. So we can say now the cost, this implies that the cost for a 400 kilometer trip, you can make it a subscript, is going to be equal to this time here that we need, which is 400 over s, into the cost per just 1 hour. Now this is going to be 1 over 200. This is s cubed plus a 10,000. Okay. Then we multiply this inside, we get 400 s cubed over 200 s. Okay. Numerators multiply together, the denominators together, plus here we're going to have 400 multiplied by 10,000. This gives us 4 million, right? Yes, it's 4 million. So we're getting 4 million. Okay, this is going to be over s. Okay, not a problem. Now, we can see that this one goes twice to there. So this is going to be 2s cubed. No, s takes out 1. They will remain with a 2. So this is going to be 2s-ish. Okay, let's just take this one out before it messes with me. So this one is out, it leaves a 2. So this is 2s squared plus 4 million over s, which is exactly what they wanted. Okay, not a problem, guys. This is pretty straightforward. So that was answering 10.1. Forgot to label. So 10.2 What is the story? It says now, calculate the average speed for a 400-kilometer trip if the cost is to be a minimum. Of course, we can just say for a minimum cost, it is such that C prime S, because we can see that this expression is in terms of speed S. So C prime of S is going to be equal to 0. This implies that we do the derivative on this expression here. We get 4S square, no, 4S plus, and then that one actually becomes a negative, because when you put this one, it becomes S to the minus 1. You multiply that in front, we get this 4 million of hours over S squared. Okay, this is equal to 0. Then, of course, mathematical gymnastics is that you multiply by the common denominator. Remember, this is over 1. This is over 1. Common denominator is S squared. So this implies that 4S cubed is going to be equal to 4 million, right? So this means that our S cubed is going to be 1,000,000 when you divide by 4. Then you take the cube root for each situation. It follows that our S is going to be, now let's see, divide by 4, and then we take the cube root of our answer there. It is 100. So this is 100 kilometers per hour. Okay, what did I do there? I cube rooted this thing, because if I want to get rid of a cube, you always do inverse operations. Okay, great stuff. So this is how it's done, guys. Easy, straightforward, no problems there. Okay, so let's get to the last question, which is probabilities. So we're told here a group of learners were asked whether they play rugby or cricket as a school sport. Then they are telling us that 45% told us that they play rugby, and then 15% said they play okiligit. And then what is the story about the rest? And then the 40% that they play, oh nope, can't be the same color. And then of course the 40% said they play neither cricket nor rugby, and none of them play both actually. So ngamabodela, or maybe the cheerleaders and all that, spectators. Come on guys, you don't want to watch things happen, you want to get involved. Anyway, represent the data in a Venn diagram. 11.1.1. Of course, you always take the sample space into some triangular box, and then you do your circles. All right, usually they overlap, but you don't even have to show that they overlap. It's not a problem. But here's what we know is that 15%, 45%, they play rugby. So this is collegiate. 15% play cricket, and then the 40% are here. They're like, thank you very much, we don't play anything. Let's see if all of this added together give us 100% to decide whether this is inclusive or not. So 45 plus 15 plus 40 is definitely 100%. So there's no manga business here. So this whole thing makes sense. Okay, so this is fine, guys. It's done. This is done. This is what they wanted you to do. So easy stuff here. So let's do 11.1.2. What is the story here? It says, now, would you regard playing rugby and cricket as independent events? Okay. What do we know about independent events? We can say for independent events, it is such that PA and B, okay, is equal to PA multiplied by PB. Why am I writing B's and whatever? Ish, this dude, come on, man. We don't have B's and whatever here. We have rugby, man, and cricket must be equal to P of rugby multiplied by P of ukhilekit. Yabona isingijwayela kabi ke manje. Now, uma sesikhilekitha kanjalo ke sithi khilekiti. Of course, they said here, motivate your answer by showing some calculations. So now, how do we deal with this one? But we know that neither play both. So this events happening together is basically 0. This is 0 is equal to 45% multiplied by 15%, which implies that 0 definitely is not equal to whatever that is. 45% multiplied by 15% is 27 over 400. You can already see that that is not, so you can say therefore the events are not independent. Okay, easy one, Bafueto, no issues there, so you sorted. Okay, so that is done. So let's sort out the last question. Okay, so 11.2.1. We're told a security code consists of 3 digits excluding 0. So you see, these are very important points, followed by followed by 3 letters, okay, excluding the first 6 letters. Okay, so what do you understand? If we exclude 0 there in terms of the digits, so the digits are 9 in total because they are 10 with 0, and then the letters excluding the first 6 letters, there are 26 in total, so we have 20 letters in total. Okay, so that's what needs to come out in your head as you get those restrictions. Now here's the big one. We are told that the digits and the letters may be repeated. This is now this whole situation set up randomly. Okay, fine. Now it says how many possible security codes can we make? So we know 1, 2, 3 digits, and then 1, 2, 3 letters. So what do we have here? If we can repeat, we have 9 options, 9 options, 9 options because we're repeating. Then for the letters, we have 20 options, 20 options, 20 options, and everything is multiplied together. This is 9 cubed multiplied by 20 cubed. So let's work that out. 9 cubed times 20 cubed. So I'm getting 5,832,000. Okay, it's quite a big number. And then, of course, this is possible security codes. Security codes. Always answer your questions in full. Ne? Don't have things that are just hanging by. 11.2.2. Now it says calculate the probability that the code will start with a 3 and end with an S. Okay, so let's see. 1, 2, 3. 1, 2, 3. So if we are wanting to start with a 3, how many options do we have? There's only 1 3 in those digits. Then the rest can be repeated. Okay, so this is 9 options, 9 options. Then we want just one S as well. So the S must be at the end. We only have 1 option over there. And the rest can be repeated, which is okay, end with an S. Remember, we can still repeat here. So this is 20. This is 20 options. Okay, we're multiplying. So therefore, this implies that the probability, okay, maybe let's not even say implies, we can just conclude. Therefore, the probability of this event, I don't know what it is, happening is going to be this 9 squared multiplied by 20 squared over the original, which is 9 cubed multiplied by 20 cubed when there was no restriction of any kind. Okay, so we have here 9 squared times 20 squared over 9 cubed times 20 cubed. So I'm getting 1 over 180. Probability can be left as a fraction, so leave it alone, please. Don't create. Oh, sekuphelile kanjalo. Okay, we can do here our 11.2.3. Okay, so let's see here. The probability that the code has exactly 1t. Okay, it has exactly 1t. Okay, now this is a tight restriction. So of course you start off by working out the numerator. Now we have our digits as they can be. So here the restriction is lifted to the original 11.2. So we can do those ones and repeat them as often as we want. Then that is multiplied by. Now we have only 1t. So there's only one option there. And then the rest, remember once we put that t, it's out. So we can only repeat the remainder, which is the 19 options for the last two positions. Okay, so this concludes that the probability of this event is going to be basically 9 cubed multiplied by 19 squared over the total, which was 9 cubed multiplied by 20 cubed. All right, let's sort it out, guys. We are right at the end of our video. So we have done pretty well, I think. Do you see when you know what you are doing? Look, I'm explaining as I go along. So if you are not explaining anything to anybody, imagine how much time you will have saved. So here I'm getting 361 over 8,000. Leave it as a fraction. It's not important to do anything. So this is the end, guys, of our paper 1 parade. So I hope you've been enjoying the videos and that you were able to learn. So this paper was quite good. There were some questions that demanded a bit of knowledge. There were some straightforward questions as well. Alright guys, I hope you liked the video and you're going to give it a thumbs up and you're going to share it with your friends, and more importantly that you have learned something out of it. Otherwise guys, like I promised, I will still do maybe one last video on functions for paper 1, and then maybe do one last video on trig functions for paper 2, and then that will be sorted for maths paper 1 and 2. And then I don't know, we'll see. I don't want to squash your time of learning, but I'll try and provide a video, because I know you need to do all the other videos, all the other question papers you can find by yourself, but I'll just do one last paper on physical science. I'll use one of these trial papers you guys wrote if I find, and then I will also do one paper for chemistry, just so that you can have everything put in order. And of course guys, good luck for your preparations. It is that time of importance where you make it count. Otherwise, from me, have a good practice session and a good study session until you get to those exams, and I hope you will do excellent. Now can you see here, we have 30 minutes to spare. So remember, I was explaining as we go along. Now when you're not explaining anything to anybody, that means you can save 45 minutes. When I was you, meaning doing matric, I used to have exactly 45 minutes to spare. I always made sure I have that amount of time to spare. so that I can go over all the questions that I've done, and especially areas where I felt I was a bit shaky. I go and have a look and see if everything is sorted, checking answers if they are correct, they make sense, no mistakes were made and all that. Because you don't need to be checking within 5 minutes. You're not going to be effective. You're just going to panic and end up messing up. So you need a bit of time so that you can take time to look through all your solutions and make sure every question is answered, and make sure all was done properly. And once you are convinced, okay, there's nothing more you can offer here, you just sit there and wait. Don't get out and say, yeah, I want to get rid of this whole idea in my... Just sit there, okay? Keep paging through that paper lazily so that you make sure by the time they say pens down, you've been checking everything and you have not found anything that you think you could correct or that you could do more on. And that says to you, your writing has been successful. And of course, it can only take the difficult questions that you could not answer to lose marks. Alright guys, bye bye for now. I'll see you in the next video.